Alright, so this problem is going to be the Levenshtein distance, and what we want to create here is to have a program that calculates the minimum amount of edits for string 2 so that we can make string 1 in this example ABC into YABD. The way to solve this, or one of the ways to solve this, is using dynamic programming. What I would suggest to do in an actual code interview will be to map out how to get into each previous problem of YABD from different points of ABC. So this is how it will look like on a table. So if you scroll here, I'm going to open a layer. You can see we have here a small table representing how we can convert from A to in this case a single space, a single blank space. If you want to convert, we have here ABC, which actually means A, B means AB, and C means ABCs, right? So from a string of ABC, how do we make it into an empty string? In this case, you can see is one edit, which is just adding A. Here you have just add AB, and here we add ABC, and here we are asking how we could make it from an empty string into an empty string. Here edit because the same thing. Y would be 1, right? Just adding Y. Then from YA we have Y and then A, then we have YAB and YABD, which is 1, 2, 3, 4 respectively. So to solve this, we have to figure out an algorithm. So we can start with the first one, which will be YA, and what we can figure out here is that Y, in order to make the string A into Y, we can just do one substitution. In this case it will be 1. Then we can see that to make a string of YA from A, we just make one insertion to the right. That can be done either by deleting A and writing YA, or substituting in this case Y for or like writing, having an empty string and writing YA, and that will take 2. Or we can have, if we just take this one, what we can say is that if A and A are the same, then it's just one edit in this case, which will be just from here, right? If we have the same thing, then we can just say that it's just one edit from the previous, from what we calculated will be for the previous problem, right? So now let's check on here. We can see here that in order to make A into YAB, we will have a minimum of 2 edits. The way we can calculate it as the easiest ways will be going to the path of making this, right? So this works like this, and it will be pointing to the right, which means that the minimum path to write YAB will be the easiest way to solve the previous problem, which is either from this path, which will take 3 in this case, which is not the most optimal. In this path we have the deleting and then writing YA, which is not the optimal, and the same here, right? YAB, and this will be like replacing, and that will be like a 4 path, right? Doesn't make sense. This will be like insertion path, and this is using the strategy here, which in this case is just adding first we add we just substitute the space with 1, then we have the easiest solution, which is just, since we already have Y, the easiest way to convert this into YA is just to add in a on the right, which means that we only have one A, and then we have this path, which is this one. So in conclusion, what we have is that we end up with this algorithm over here, and the idea is that if A is equals to A, or if if we are going through the matrix and the column and the row letter is the same, then we can say that it should be diagonally this one, because if we go diagonally to the last one, means solving the previous one with just one of difference, right? Yeah, we can say, I think here, if that's the case, then we can see that it is the same, right? Because if we go diagonally back, then we can say that it takes the same amount, because in this case we only have one space, but here we have the same letter, right? Which means that now we don't have it to add an A in order to have that solved. We can just use what was the algorithm that we used creating the thing before the A was inserted there, and since now we have an A, we just say one space, which makes it become the same time that it takes from the previous problem of the initial array element, right? And now let's go over, and otherwise what we can say is that, okay, if it's not the same letter, then what we can want to do is find out what was the shortest path to the solution, or what's the previous walkthrough to that solution, and then adding one, which is the addition, right? Or addition or subtraction. In this case, for example, if you want to solve from 1AB from space, then that means a deletion, and then writing 1AB, which will be an additional plus 1. And here what we have is that if we take from the previous one, it's just putting an addition, right? While yeah, that will be just the thing. So let's see how that works on code. I'm going to be declaring const, and we create like an array, like edit, and this will be our matrix, and then we first create the first rows and first columns, and what we can do is for let I equals str to the length, because we want to include also a space before that, so we want to make the algorithm, the matrix, one extra column and one extra column width and one extra row tall, right? So let's go over here and let's write the for let and we say edit. We have to create the row, but it is the edit y j are going to be equals to j, and then we say that edit I O is going to be equal to 0. I think that's the 2 for loops over there. And then what we want to create now is, once we have the for loops here, we want to calculate, we want to use the algorithm, right? So I will say copy paste this part. I said that now you want to start from 1 to skip the first row, first column, and you calculate this as follows. And you have to be careful here because we are taking the string, and since this one starts with 1 but the string starts with 0, right? So you can see that it was a 1 but this is index 0, right? So what we want to do is that to ask if str1 I mean minus 1 is equals to str1 j minus 1. Then I want to print then we want to take the diagonal one, which means that edit I j is going to be equals to the diagonal of that, which is minus 1 minus 1. Otherwise we want to take this as the minimum between the diagonal and right and left, right? This is going to be math.min let's just remove this. There we go. And then what we want to return is going to be the last one, yes, the last one, right, which is from here to here, and that's going to be, I think we can use I j actually. Let me check. Nah, just in case I'm just gonna leave them as str length str1 dot length. Oh, let me check. Fail. Okay, let's see. Okay, what do you do here? I don't mind. Oh, right. Okay. Let me. Okay. So we do like, because we can directly edit it, or we will have to like create a matrix, but this is one of the ways to do it. Then we like row, then over here we push j. Let's see. Edit. Oops. Alright. At least one of it works. Now I want to see Oh, this is not working, right? Oh, this is tier 1 minus equals let's see. So the first one, because it's going to be a space and y, then we check that it should be 1, right? Yeah, and I forgot to add a +1 here. Yeah, almost there. What? 16? What happened in 16? Almost there. So let's go over 16. None. It seems that they have some extras over here. What's going on? Am I going over more? Oops. I think so. There we go. Yep, that works. Alright, thank you very much. You can see that the audio quality improved a little. I invested a little of my money to purchase a mic, so I can... Oh, I forgot to record my camera today. Okay, next time.